Hi all, so we will be presenting on the 4 steps of pharmacokinetics, which consist of 4 steps of process, which is absorption, distribution, metabolism and excretion. So these are basically designed to investigate how a chemical, example a drug compound, is being processed by a living organism. Absorption will happen when a drug administered from its formulation or admin site which can enter into the bloodstream. This happens through the ingestion through the digestive tract, inhalation via the respiratory system, dermal application to the skin or eye, injection through direct administration into the bloodstream. So this process will happen in possible routes of the administration, with the two most common, which are intravenous and oral. So if a drug administered intravenously, the absorption phase is skipped as the drug immediately enters circulations.
The second step, distribution, describes the journey of the drug through the bloodstream to various tissues of the body. The process of drug distribution is important because it can affect how much drug enters up in the active sites and thus drug efficacy and toxicity. A drug will move from the absorption site to tissues around the body, such as to the brain tissue, fats, and muscles. There are many factors that could influence this, such as blood perfusion, polarity size of the drug, regional pH, permeability, and binding capacity. For example, a drug like warfarin is highly protein bound, which means only a small percentage of the drug is free in the bloodstream to exert its therapeutic effects. If a highly protein-bound drug is given in combination with warfarin, it could displace warfarin from the protein binding site and increase the amount that enters the bloodstream. Additionally, there are anatomical barriers found in certain organs like the blood-brain barrier, preventing certain drugs from going into the brain tissue. Drugs with certain characteristics like high lipophilicity, small size and molecular weight will be better able to cross the blood-brain barrier.
The third step in the process of ADME is the metabolism. Metabolism refers to the biotransformation of non-endogenous compound to products suitable for body elimination. This process can be divided into two, which is modification and conjugation. During the first step of metabolism, molecules are modified by involving formation of a new or modified functional group or cleavage through processes such as oxidation, reduction, and hydrolysis. These reactions are non-synthetic and it changes an inactive product into a metabolically active drug.
In the context of metabolism, conjugation refers to a specific type of biochemical reaction in which a molecule, often a foreign or non-endogenous compound, is chemically modified by attaching another molecule to it. This modification typically makes the compound more water-soluble or more easily excreted from the body. The functionalized metabolites produced in phase 1 are further modified by conjugating them with endogenous molecules. The goals for conjugation is to form water-soluble product that can be secreted from the body. In conjugation reactions, the modifying molecule is usually an endogenous substance, such as a small molecule like glycerolic acid, sulfate, or amino acid, which is covalently attached to the original compound. This attachment is often mediated by enzymes in the body, particularly in the liver, where many conjugation reactions take place. So the purpose of conjugation reactions is to transform potentially harmful metabolizable substance into forms that can be readily eliminated from the body via urine or bile. By adding a water-soluble group to the original compound, conjugation reactions increase its polarity, making it easier for the kidneys or liver to filter it out of the bloodstream and excrete it. So overall, conjugation reactions plays a crucial role in the detoxification and elimination of antibiotics, or we call it as foreign substance, and metabolic waste product from the body, contributing to the maintenance of homeostasis, and overall health.
Finally, after metabolization, there is an excretion where the drugs or its remnant exit the body. This is typically done via exhalation, sweating, urination, or defecation. The mechanism of excretion in ADME involves various physiological processes. This process occurs through several organs, primarily the kidneys through renal excretion, liver through biliary excretion, lungs through pulmonary excretion, and also through other routes such as the sweat glands. The kidneys play a crucial role in eliminating many substances from the body. Substances are often filtered out of the bloodstream by the kidneys and excreted in urine. The liver is responsible for metabolizing many substances through enzymatic reactions. Once metabolized, the substance or its metabolites may be excreted into the bile, which is then eliminated from the body through feces. This process is known as biliary excretion. Some drugs are metabolized into gaseous form and excreted through the lungs via exhalation. This process is known as pulmonary excretion. Glands that produce fluids such as saliva and sweat can also promote excretion. However, these routes typically contribute minimally to overall excretion process.